In this video, we're going to discuss what to do when we have a product or a quotient of functions inside of something that we're trying to take the derivative of. So if it's not a function, if it's just a single constant, then you don't need to worry about this. But when we have some function of x times another function of x, what we say is we kind of go left to right. And whatever we get to, we take the derivative of first. We can only take the derivative of one thing at a time. So first we take the derivative of f, and then g just kind of hangs out there. And then we add, and then we go back the other direction, and we take the derivative of g, and then f kind of just hangs along for the ride. And that's it. There's no need to simplify. The quotient rule is very, very similar, except for one difference. When we read, we go left to right, so that's why in the product rule we start left to right and then we go back right to left. We also read top to bottom, so when we're doing the quotient rule, we go top to bottom. So we take the derivative of the top guy first, and then the bottom just kind of hangs out, and then instead of adding in the quotient rule, we subtract, and now we go bottom to top. So then we're going to take the derivative of the bottom function times whatever the top is. The big difference here is that if it starts out as a quotient, it must end as a quotient. So whatever's in the denominator, we take that and we square it. So that's the biggest difference there. So an example here, we have a product rule. We have the product of two functions. So I'm going to go left to right. So first, I take the derivative of the first function. So I'm going to get 6x minus 4. And then this second function is just kind of hanging out. And then I add, and now I go back the opposite direction. So now I take the derivative of the second function, which is 1, times everything in the first. There's no need to simplify it unless it tells us to do something else with this. This just said take the derivative. This is the derivative. That is our answer. The second example here, now we have a quotient rule. So we have a function over top of a second function. I read top to bottom. So I'm going to start by taking the derivative of the top function, which is 3. And the bottom function is just hanging out. Now I'm going to subtract, and now I'm going to go bottom to top. So now I take the derivative of the bottom function, which in this case is 2x. And now the top function just hangs out. It's really important if any of your derivatives are more than just a monomial that they go in parentheses like these guys here. Okay? In the quotient rule, we also have a denominator, so we take whatever was in the bottom and we square it. We should always label our answer, but again, a lot of times there's no need to simplify. Unless we need to look for more things, then we may want to clean this up a little. Okay, so here we're going to avoid the rules if we can't. The rules are kind of ugly. They require a little bit more thinking. So in this case, when we just have a constant in the denominator, let's pull him out front as a fraction. So in front of this polynomial is a 1. So there's really a 1/8 out in the front. And then this is really x squared minus 4x. And the nice thing about that is now when I take the derivative, anything that's a coefficient just drops down. And I have no fancy rules. All I have to do is take the derivative of this function, which is 2x minus 4. So here are the derivatives of trig functions. These are the 4 I think you should memorize, only because they come up a lot, and I lied. These 2, sorry, are not the 2 to memorize. I've already asked you to memorize sine and cosine. These are the other 2 you should memorize, just because they're fairly simple and they appear a lot. So the derivative of tangent, secant squared, the derivative of secant is secant tangent. Each one of these rules has 2 secants. So here there's 2 secants, here there's 2 secants, and 1 tangent. That's kind of how I remember which is which. The other ones, we could actually write cosecant, we could write as 1 over sine, and then we could just do the quotient rule. So I would not bother with memorizing that unless you really want to. Okay, so example 6. Again, here we do have to use the product rule because we are multiplying 2 functions of x. If this was a constant, we would not need to do that. So we're going to go left to right. For my derivative, I'm going to take the derivative of x first, which is 1, and then the secant of x just drops down. I'm going to add because this is the product rule, and now I'm going to go back the opposite way. So now I'm going to take the derivative of secant x, which is secant x tangent x, and then I'm going to drop down that second term. Be careful that you don't throw this x inside that tangent. So either somehow make it separate like this. A lot of times we'll write that in the front and we'll write it as x secant x tangent x. That way we know that it's not inside of this tangent here. It's totally separate. This we could clean up if we needed to, but again, if it doesn't tell you to go further, just quit when you're done taking the derivative. Higher order derivatives, again, we've talked about this already. First derivative is velocity, second derivative is acceleration. Here's some different notation. We usually don't get up to third derivatives because they don't have a lot of meaning in a lot of our problems. The notation a lot of people don't remember is this one right here. This is the second derivative of y with respect to x. Again, it's just another way to denote the second derivative, and you will see that on the AP test. And that's it.